Okay, what I'd like you to do is draw this picture with that label in your notes. So our function g is what we call an accumulation function. Why do I call that an accumulation function? What is accumulating? Right. And so in this specific case, what measurement is accumulating? What is that integral calculating? The area, okay? Area is accumulating under the curve. That's what we call the accumulation function. Okay? So G is defined as a function from 0 to x, the integral of 0 to x of t dt. Okay? So this is what we need to find. First of all, I want us to find G of 1. If I'm going to find G of 1, what does that mean? That means we have the integral from 0 to, instead of G of x, this is G of 1, so we're plugging 1 in for x. Okay, so that's asking us for the area under the curve from 0 to 1. What is it? Okay, we have a 3 by 1 triangle, right? From 0 to 1, we have this area right here. Okay. Now, here's where it gets fun. Let's talk about G prime of 1. What's the relationship here between F and G? Joe. He posed a question. Wouldn't G prime just be F? Okay, let's talk about it. If we take the derivative, G prime of x, what's the derivative of this antiderivative? F of x. Okay, so when I ask you for G prime, okay, back up one more time. This graph of F is the graph of the, it is the derivative of G. This is the derivative graph right here. So when I ask you for G prime of 1, I'm asking you for F of 1, which is 0. And then if I'm going to ask you for the second derivative at 1, then that's the same as F prime at 1. What do we look at on this graph of F? The slope. F prime deals with the slope. Okay, so the slope at 1 would be what? -3. Okay, so now we're kind of morphing together a little bit of Unit 3 here with our integral unit. Unit 3, we did a lot of graphical analysis. Okay, we're bringing that back. Okay, what do I mean? I want to know where the function g of x is increasing and decreasing. Okay, if I want to know, do you guys have a question? No? Okay. If I want to know where g is increasing or decreasing, I would like to look at the derivative. Where's the derivative? F is the derivative, right? Graph of f is the graph of g prime. So, where are we increasing and decreasing? Tell your neighbor. Okay. Trevor, where is g increasing?
From -2 to 0.
And why? Okay. Let me remind you of something, Trevor.
Oh, yeah. -1.
We are increasing from -1 to 1 because, okay, that is where our derivative has positive values. And where our derivative has positive values, that means our function is increasing. Okay, so let's talk about decreasing. Michaela, where would our function be decreasing?
-2
Okay, -2 to -1 and 1 to 2 because that's where our derivative is negative. Okay. We're wrapping our head around that idea one more time. Okay, how about if I ask for the concavity of g of x? Turn to your neighbor and tell them what we need to look for the concavity. Okay, concave up. Eli, where is this graph concave up?
Is concave up from -2 to 0.
Why?
Because it's crossing from, it's going decreasing and it's increasing. And it crosses the x-axis.
I agree it goes from decreasing to increasing, but is that why it's concave up? Oh, I see right here. Okay. You're visualizing. Okay. That explanation isn't always going to work because I could draw this picture, decreasing and increasing, and that would not be concave up. So let's think of a solid, going to work every time explanation.
Cap on a friend.
Yeah. How about at your table?
Table. I need help. Can we do a long distance call?
Sure. Who can help you lay out here? Okay. Our derivative is increasing, which means the derivative has positive slope, and the derivative, I'm giving words here. We're looking at the second derivative, which is the derivative of the derivative. Derivative, we look at slope. So here's our derivative graph. We look at the slope of the derivative to get the second derivative. So since we have positive slope from -2 to 0 on our derivative graph, that means our second derivative is positive. Okay. Well, where are we concave down?
From 0 to 2.
And how do you know that?
Because
Okay. Because our Derivative has negative slope. Very good. Okay. All right. Now, that wasn't too... Well, 2 and 3, not any different than what we did first semester. We just needed a reminder. Up here, we plugged in 1 to the function. We took the derivative, plugged in 1, took the second derivative, plugged in 1. How about if we have g of negative 1 and g prime of negative 1? How is that going to be any different? Let's talk about g of negative 1. Okay, our g function is the integral from 0 to x of f of t dt. I'm taking the integral from 0 to negative 1. Oh, yeah, you can. But what's true about it? We go backwards, okay? So it's going to be the opposite of whatever we find. So what is the area from, let's say, negative 1 to 0? Okay, so if we went from negative 1 to 0, it's above the x-axis, it would be a positive 3/2. But since we're going backwards, we have to negate it. So this would be a negative 3/2. Okay. G prime of 1. Remember, we decided that G prime is the same as F. So what is F of negative 1? 0. What do we call it when our derivative is 0? It is a what kind of point? Before we determine that, we call it a... What's the C? What's the CR?
Critical point.
Critical point. When our derivative is 0 or undefined, we call it a critical point. Okay.
You can spell it out. That's it.
My 3-year-old, when he is trying to give us a hand, he goes, "David, what is it, Mommy?" I don't know. I think the other day, Mommy,